So now let's look at an example that might be similar to what a surveyor might encounter. Here we have Ben who wants to measure the distance across the Big Muddy River. He determines that angle C down here is 117.2 degrees. He knows that angle A up here is 28.8, and he knows that this distance over here, B, is equal to 75.6 feet. And what he's trying to find, though, is he wants to know how far is it across the river. So how can we use the law of sines to do that? Well, in order to use this side B over here in the law of sines, I would need to know what the angle B was that corresponded with it. Since I know angle A and angle C, I can use the definition of trig angles, or the definition of triangles to find out what this missing angle is here. So we could say that angle B is 180 degrees minus angle C, which is 117.2, minus the 28.8, which is over here, angle A. And we know then that angle B has to be 34 degrees. So since I now know angle B, I can use the law of sines, which says side B over the sine of B equals side A, which is ultimately what we want to solve for, over the sine of angle A. Angle B is 75.6. We know that from what we're given. The sine of angle B is, we said B is 34 degrees. We set that equal to A divided by the sine of angle A, which is 28.8. Now when we cross multiply and solve for A, we end up having A is equal to 75.6 times the sine of 28.8 divided by the sine of 34, and we see then that A is equal to 65.1 feet if we round to the nearest foot. So that allowed us to solve for this distance across the river. And that's kind of just an application of using the law of sines.